Hey guys, welcome back. So today I brought home this Yamaha 3000 watt inverter generator. And this one I don't know anything about because they threw it away at the dump. Anyway, I know someone who knows someone who has access to stuff at the dump. And they reached out to me and asked me if I wanted it. So yeah, a Yamaha inverter, definitely interested. Anyway, this, when it was new, was an expensive machine. They sold for about $2,000, and even in running used condition, they fetch a pretty good price. But as you can guess, this one doesn't run. Haven't really done much to it, but I did pull the engine over, and it feels like there's little or no compression. So I'm actually kind of relieved at that, because the only other reason I can think of that someone would throw this away is if the inverter module itself was bad. And they do sell the inverter module, but it's about $1,500. So if that was broken, then that would sink this ship pretty much before leaving the harbor. I can tell someone has obviously been in here. We are missing panels for the inverter as well as the battery. I do have this one here, which is for the oil fill access port. And here on the back, kind of the same story. This panel was removed, but at least I have it. I don't know what's going on with this, but I can tell someone was trying to figure out what was going on. And if you look in here, we also have a critter, but I don't think that has anything to do with the lack of compression. So let me set up a little bit better. I think I want to get a compression tester on this and just see kind of where we're starting off at, and then get that valve cover off and see if there's anything obvious going on. Believe it or not, this has a good battery, so I'm just going to turn it over with the electric start. Wow, I wasn't expecting to see that. We're at about 70 psi, so yeah, this should fire. Now it has me concerned about the inverter. I really am quite surprised that the compression test came in as well as it did. Before I brought this home, I pulled it over several times, and there was no detectable compression. But when I pull the cord now, we hit compression, and the cord just advances very slowly. And that's the way it should be. So I'm not sure what changed. Potentially that spark plug was not tight. I'm not sure. Let's get the spark tester on there and see if we have spark. Yeah, we got spark. It's a little hard to see, but it's there. I'm going to put a little bit of premix in the cylinder, see if it'll fire. Yeah, I suppose we should check the oil. Okay, we got oil. It's way, way past due, but it doesn't smell like there's fuel in there, so it should be good enough at least for a test. All right, let's give this a try. I have a light plugged in and turned on in the unlikely event this is going to run long enough to power that inverter up. That engine sounds great. I was hoping for a little bit more, so I'm going to refuel and try it again. All right, I don't know if you saw it, but that light flashed for a split second. So there's hope. Let's try it again. It's just not running long enough to see if that inverter works, so I'm going to try putting a little bit of fuel in the tank, and we'll try this again. Well, that's what I was afraid of. I'm pretty sure this inverter's toast, but I haven't given up hope yet. I noticed a few things. The one time it made power, when it shut down, the eco switch became unresponsive, and the overload light blinked just for a second. And if the inverter was bad, I wouldn't expect it to be trying to make power, and I would expect that overload light to stay on constantly. So that's giving me a little bit of hope. Also, there is a mouse nest in there, so we could have some chewed wires, and if the right wires are chewed, it could be creating a short circuit. And there's no AC breaker on this unit. It's actually up to the inverter itself to detect a short or an overload and shut down to protect itself. So maybe, just maybe, that's going on here. Anyway, to get a better look, I need to start getting some of these outer layers off. I've got several carbon monoxide detectors in my garage, and this isn't the first time I've worked on one of these Yamaha EF3000s, and all of them have put out a lot of carbon monoxide. not seeing much evidence of a mouse here other than the nest down below and some chewed insulation here, but I don't see any chewed wires, so I don't think that's our issue. Now, as far as the wires themselves go, I've been able to kind of figure out what most of these things are. You know, we have the stator on this side with two main bundles coming out. This one is 3 yellow wires, which is the high voltage 3-phase AC. So I do want to check the resistance of that, make sure we're good. And here we have a bundle of 4 wires, 2 orange, 2 blue. I'm assuming that's a lower voltage AC out that is then rectified to DC. Over here we have the same 3 wires coming out of this box, and those are the inputs to the inverter. This here is the output of the inverter, 120 volts. And this bundle most likely is the status lights and the eco switch control. Anyway, 2 things stand out here. I guess first, the wires going into this box and out are not protected against mice, meaning the opening is quite large and a mouse could definitely get in there. So I do need to open this up and just make sure there's no damage. Also, if you look at these capacitors on the inverter module itself, I think these are supposed to be identical capacitors, but if you look at the one on the right, we have this brown, looks like piece of plastic on the top of the capacitor, and on the left one we don't have that. Also, this here is ripped, so if I had to guess, I'd say that is most likely the issue with the inverter, and unfortunately that is not serviceable. This whole thing is potted. Anyway, let's get the meter on the stator wires and see where we're at as far as resistance goes. Okay, on this leg we're at about 0.8 ohms. Leg 2, the same. And same on leg 3. So that appears to be good. So we'll check the blue wires first. Point 0.1, that is pretty low. This meter has an internal resistance of 0.1, so that's just about 0. We'll check the orange wires. We're at about 0.2, 0.1, so similar reading. So the yellow wires go through this box and then out. So I'm going to check the connector over here as well. Make sure we get that same reading of about 0.8 ohms. Yep, that looks good. That's good. And same there. So I would say the input to the inverter is good. Now, I don't know what the ohms readings should be on this. I'm going to try to look it up now. But the fact that all 3 legs are consistent, I'd say is a very good sign. And nothing standing out here. The wiring looks good. I don't see any chewed wires. On the right side, there is a little bit of evidence on the bottom that there was a mouse in here, but Not seeing any issues with the wiring itself. The only thing that stands out is this green light right here. It looks damaged on the top, and I'm not sure how it got over there. I mean, someone must have been in here because that green light actually belongs way over here. Now that I can see the green light, I'm just going to try starting it like this. There should be some fuel left in the bowl, so it'll run for a few seconds with any luck. There's just one more test I want to do here. I've back probed one of the legs, and I want to get this started again. If the stator's working, depending upon the engine speed, we should see somewhere between 2 and 400 volts AC out of leg 1. If we do, we'll repeat the same test for leg 2 and leg 3. Now, I've also got the light hooked up just so we can see if there is any AC output, and we also have the green light back where it belongs so we can see what's going on with that. And I've also rigged up the test tank. So this is getting some fuel. So let's get this started up, see what the voltage is at coming out of the stator, and go from there. That was interesting. The inverter did power up. Seems like it only would do so when the eco throttle was off. And we got plenty of voltage out of leg 1. So let's switch to leg 2 and repeat the test. Same thing on leg 2. Let's try leg 3. not sure what to think about this one. The output on leg 1, leg 2 was around 220 volts, but leg 3 is about 100 volts more at 320 volts. And the inverter actually seems to be working when eco throttle is off, and that is basically increasing the voltage across all 3 legs. So potentially it's not an inverter issue. Anyway, I need to do some homework on this. I'm going to take a look for a service manual and see if that gives me any clues. It's been a couple days and I've done my homework. I managed to locate the service manual and it had some useful information in there. And I guess first off, it had a resistance table of the expected values on a healthy stator for both the main 3-phase coil as well as the secondary single-phase coils. And the readings I got matched the service manual perfectly. So I think we're good there. The second piece of information was the expected voltage out on the 3-phase system at 3600 RPM. It gave a good range between 200 and 250 volts, which, I got 220 volts on leg 1 and leg 2, but not leg 3. I was almost 100 volts higher at 317 volts. So that had me concerned. That reading is out of spec. And I guess the confusing part is that the manual said to only check 2 of the 3 legs. And that one got me thinking a bit as to why it said that. But I guess when it comes down to it, this is in a Y configuration. And if you check any 2 legs, you've actually just checked all 3 coils and all 3 yellow wires coming out. So checking the third one is kind of redundant, but that doesn't explain the reading I got. So I went back and checked the footage and found out that it wasn't 317 volts. It was actually 0.317 volts. So I'm guessing I didn't back probe properly. So just for peace of mind, I'm going to start it again. We're just going to back probe the leg 3 again and hopefully get the voltage we expect to see, 220 volts. I'm glad I double checked that. There would have been doubt in my mind as far as the final diagnosis, and probably yours too, but the facts are the voltage output on all 3 legs are within spec, and so is the resistance. So there is nothing wrong with that generator head. It's doing exactly what it should. And unfortunately, we're running out of things to test here. I don't have any equipment to directly test the inverter module, but what I'm doing is just eliminating all other possibilities. And there's only one other possibility that I can think of, and that is the engine speed itself. The inverter seems to work with the eco switch off. So the engine's running at full speed, which should be close to 3600 RPM. And when I turn the switch on, that's when the inverter goes out. The engine should be running at 2800 RPM. If it's running slower than that, then that could definitely cause the issue we're seeing. So I'm going to get a tachometer hooked up and we'll get this restarted. We'll turn the eco switch on and just double check that engine speed. And I'll also turn it off and double check that the full speed is close to 3600 RPM. And at that point, I think I'm just going to load it with a space heater to about 800 watts and see what happens. About 2800, so that's perfect. And I'm going to speed the engine up. I want to try an 800 watt load. I'll start with the good news. The engine speed was dead on, both with the eco switch on and off. Unfortunately, I think this inverter is shot. We've pretty much eliminated everything. And this time, we had the AC light on, the control panel, the light bulb was on, and I tried to power an 800-watt load. And not only could it not do it, but it couldn't even turn the fan on the heater. So I would say 100%, we need a new inverter. We've pretty much eliminated everything else. And unfortunately, that inverter exceeds the value of this generator by about $600. And I know people are going to be writing in the comments that they found one for an EF3000 for $800. And that's true. There are ones out there for that price. Unfortunately, there's 6 revisions of this generator. And this is the first revision. It was only made in 2002, 2003. And the inverter module that's in there is unique to those 2 model years. So I have to replace it with the exact part. And the price for that part is $1,500. Now, I did shop around a bit, and I found a few that were cheaper. I think the cheapest I found was about $1,200. But even that exceeds the value of this generator by at least $300, if not more. And that's too bad, because this otherwise is a good machine. And to swap out that inverter, it's about a 10-minute job. Now, I am tempted to do a teardown video on this, but I think I'm going to wait until this video airs, because someone watching could have a parts machine in their possession and potentially a working inverter, or maybe someone's an electronics guru and can depot this inverter module and repair it, or know someone who can. So I'm going to roll this one in the corner. I'm going to let it sit a bit. I've also put some watches out on eBay. So at some point, I'm sure someone will put one up for sale, but it's just a matter of how long. Anyway, I hope this video helps someone. Thanks for watching.